All right. Yo, yo, yo. I'm back with another set of lead code questions. Okay, let's get this done, guys. So, I did what yesterday? I did binary search. I'll be right back. I'll be right back. So yesterday we did binary search. So today we'll try doing graphs. 13 questions. Let's get it. Number of islands, max area of island. I've already attempted and done. Let's get this done with clone graph. Okay. So we have to simply return a deep copy of the graph. Deep copy means we have to copy, basically allocate new memory to all of the nodes in the graph that is given and return a copy of that graph. That's all. Okay. So so we need to keep track of the old nodes and new nodes, right? So we probably need a map for that, an ordered map of from node to node. Let's call it old to new map. Let's call this CP or MP, or let's say what can we say? Old to new mapping. What's a good variable name for that? Let's just call it MP, and this is a mapping from old node to new node, fresh node. Now here we can simply check if mp.find node is mp.end, then create a new node with the value of this node, right? And then mp of node equals copy, and then for every neighbor of this node we do a recursive call here, right? Recursive call, I mean neighbor in node neighbors, clone graph neighbor. Else, if that node is already present, then we still okay, I'm not making connections here, by the way, so interesting. Is there any add neighbor here? Nope. So copy neighbors dot push back this, right? Instead of copy, let's do mp node and return mp node. So we can simply we can move this out of this if block, right? Let's see if this will work. Now, can node be null pointer? It can. So if not node, then return null ptr So we check if the copy of node exists. If it doesn't, then we create a copy and then assign it to the map. Then what do? Then we go to each neighbor of the current node, and then we add to the neighbors of the copied node. Clone graph. Yeah, makes sense. Let's try this out. Okay, Stack Overflow. If mp.find node is mp.end. Okay, Stack Overflow. Why? $28.43. Do we need to keep track of visited as well? Is it a undirected graph? Okay. Undirected. So yeah, we need visited. So we can simply do. How many nodes are here? The number of nodes are in the range of 0 and 100. Okay, let's. The value can be anything, right? Is unique for each node. Unique for each node. Let's try this. Expected parameter declarator. What? What's wrong with this? Visited 101 false. Expected parameter declarator. Okay, so I can't use that in a constructor. Okay, since there are only 100 of these, let's just use an unordered set. Let's ditch this. If visited.find node val is not equals visited.end, means it has been visited already, then we return. Otherwise, visited.add node val, and this will be an int, right? Yep. void function. Return empty node. No insert, is it? Push insert. Okay. Runs successfully on the test cases. Let's see the actual submission. Okay, it works it, but it is kind of slow. What are we doing wrong here? Yeah, I mean, I could have done this in with the neighbors. Let's see my previous solution. I did this on Feb 10th. This is kind of an ass solution, but it is in Java, so fuck this. Let's see this. Okay, this is also slow. If not node, then this. If copies.find node is copies.n, then we create a new copy. Then we go to neighbors, copies node neighbors, push back this, exactly the same. Return copies of node. Here I am not doing the visited thing. Why is this working now? Oh, yeah. Interesting. I could have just done this, then I don't need this bullshit. Yeah, that's fair enough. Let's see if this is any faster. Okay, fairly faster. Yep, it's good. Okay, so the time complexity is simply order of n, where n is the number of nodes in the graph. So yeah, analyze. Let's see. I believe it is order of n. We can see the solutions. Let's see this guy. What's the time complexity, my brother? Time complexity of DFS. V plus E. Okay, yeah, vertices and edges, that's fine. Let's see this guy. Could have done BFS also, but DFS is way shorter, as you can see, and it is cleaner as well, so that's why. So it's just a DFS. Let's do the next one. Walls and gates. Subscribe. What? Walls and gates. Let me check if it is in any other website. I think this is the thing. I can see the lead code thing. Okay, is this on neat code? Yep. Islands and treasure. Oh, this is perfectly fine, brother. Let me just get back on here. Open this list. Okay. This is fine, so I don't need this. Okay. You are given an m by n 2D grid initialized with 3 possible values. -1, a water cell that cannot be traversed. 0 is a treasure chest. INF, a land cell, infinity. A land cell that can be traversed, we use integer 2 to the power of 31 minus 1 to represent INF. Fill each land cell with the distance to its nearest treasure chest. If a land cell cannot reach a treasure chest, if a land cell cannot reach a treasure chest, then the value should remain infinity. Assume the grid can only be traversed up, down, left, or right. Modify the grid in place. So it's kind of a multi-source DFS. Yeah, that's correct. So we start BFS from every treasure chest, and then we simply minimize the distance of each land node if it is accessible. If none of them is accessible, then fair enough. You know what I mean. Can we do multi-source BFS all at once? Well, does that make any sense? I don't think so. Even one by one is fine, right? But I have to find all of the treasure chests first, and then push them into some sort of vector, and then traverse them, right? Let's see if anything else can be done here. Bum 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 bow 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 bow. And what does multi-source BFS mean? I mean, all at once. What the fuck does that even mean, bro? I don't even care. Let's do one by one. All right. So we simply store treasures, points, treasure coordinates. Let's just call it T coordinates. Then for also, let's do this first. I'm traversing this grid to find out all of the coordinates, basically X and Y, of every treasure chest. So I know the origin of the BFS where I want to start from. So int I equals 0, I is less than m. If grid of I j is 0, then t codes dot push back ij. Now, okay. So the time complexity of the solution that I'm trying to do is, it will be number of treasure chests T multiplied by BFS. Yeah, BFS time complexity is same as DFS, right? Vertices and edges. Yeah, so it's just this V plus E, right? Or am I tripping? BFS time complexity in adjacency matrix. It's not adjacency matrix exactly, so it's whatever. Okay. Okay, let's go ahead, man. All right. For int, let's just do this. Coordinates in T coordinates. Int x equals what am I doing? This is a pair. So now I just need to perform BFS on this. So let's write a different function for that. BFS on grid starting from X and Y. Do we need anything else? That's all, right? Then nothing, right? Okay, so void BFS, we need the same grid passed as reference, then int X and Y, where the treasure chests are. So we just do a BFS here, right? So for BFS, what do we need? We need a queue, right? Do we also need a visited array? I mean, I can probably deduce visited from the values itself. If it is infinity, then it is not visited, otherwise it is visited. Also, I just have to minimize everything, so I should probably have visited in here, right? M and N are 100, so it's fine. Okay, so let's do vector of bool visited of size M and N. Let's also pass them q dot push X and Y while Q is not empty. Then we get the current coordinate Q dot peak, right, or front, Q dot front. So X equals Q dot front dot first, Y equals Q dot front dot second, Q dot pop. Then I can go up, down, left and right. Let's create direction vectors for these. So vector, since these are common, so let's do it here. Dx equals go in all 4 directions. Also, I need size, so int size equals Q dot size, right? While size minus minus, and then we do all of this. We need layer by layer thing. For int I equals 0, I is less than 4, I plus plus. Then we calculate xx, which will be x plus dx of I. Y equals y plus dy of I. If visited xx y, then continue. Otherwise visited xx y equals true. And then grid of xx y equals minimum of grid xx y, minimum of this, and we need to keep track of distance. Int distance equals, initially it is 1, right? Okay, go in for all 4 directions. If it is visited, then continue. Otherwise visit it and update the distance here. Right? And should I just avoid going in that direction if it is not minimum? No, I shouldn't. I shouldn't. There can be a case like, you know what I mean? Interesting. But that's I don't know. I don't think so. I mean, we can try, of course. Yeah, yep. We should do that. Okay. So if distance is less than grid xx yy, then update that distance in the grid and push it to the queue. Q dot push xxyy. Right. Also visited. Also we need to check out of bounds if xx is less than 0, or if xx is greater than equals m, or yy is less than 0, or y is greater than equals n. Then continue if grid xxyy is 0, not 0, -1, then continue. So we can combine these two if conditions. Okay. Rohan Gupta subscribed. Thanks, brother. Thanks for subscribing. Just doing a couple of lead code questions in here. That's all. Okay. So first of all, we find all of the coordinates of treasure chests. Then we traverse those coordinates. Then we do a BFS, right? And in BFS, I'm also passing M and N. Let's do that. Then in BFS, what am I doing? I create a visited thing. I create a queue. I push that treasure chest coordinate because that's where I want to start from. Then I also create a distance. Then while queue is non-empty, then I take first layer of that BFS. I run BFS on it. So how do I do that? In XY, I get the coordinates. I pop it from the queue. I go in all four directions. If they're out of bounds or visited or non-traversable, then we continue. Otherwise, we visit that, and then if distance is less than the given grid distance, we update the grid distance and push it to the queue. And after each layer, we increase the distance. Right, let's try to run. Okay, it is accepted. It is pretty fast. What the fuck? Submit. Invalid pointer. What happened? Past test cases 11. What happened here? Input expected output. Free invalid pointer run.sh line 1 3 aborted code dump line 1. Oh man. Use test case run. Segmentation fault. What happened? Is it like some out of bounds shit? No. No, right? So we have just, okay, 1 and 2. 1, 2, 3, 4, 5, 6. What? Out of bounds access, dereferencing in null or initialized. Use after free, accessing invalid to memory, dangling. Okay, interesting. Out of bounds. Am I doing something bad here? Have I done a poo-poo? Have I done a 1, 2, 3, 4, 5, 6? I can probably do some C outs and check what is happening, right? Let's do here. C out X, Y. Let's see what's wrong. STD out. There is no STD out here. Okay. Wait a minute. Wait a minute. Wait a minute. Wait a minute. Visited XY is true. Okay. Let's do here also. IJ. Treasure found. Brother, what's wrong? What's wrong? What's wrong? Why isn't this? Okay, STD out is not here. Okay, it's no, I can't debug. Damn, man. Shit. Let's search some other website, walls and gates. Or we can even see the explanation of this. Fuck it. You should aim for a solution with order of m by n time and m by n space, where m is the number of rows in this. Okay. Infinity visited rows goals direction this. DFS. Why are we doing DFS? Brute force. No, DFS. Directions BFS Q, Q visited, correct. Then visit this true steps 0 while Q is non-empty, size, get the size for each size, then get this, get that. If it is 0, then return steps. If grid row 0, return steps. Okay, if we have found the treasure chest itself, then okay. Then for each direction, go to that direction. If it is out of bounds, then okay, and not visited and not -1, then visited and then push. And are we comparing the fucking okay, so there is slight difference here. Let's look at the thing that we did here. So one thing that is different is this guy is not checking this, right? But it's fine. I believe this condition is all perfectly fine. And he's starting from steps as 0, right? Is he pushing as steps +1? Where is he updating steps, bro? Where is he updating steps in the grid? That's the question, bro. Oh, here. Return infinity, return steps. Oh, okay. Okay, okay. Okay, what's happening here? Grid Q. We push all of the treasure chest coordinates in the queue. Then we see that Q is non-empty. Then we get the current thing. We go to all 4 directions. If it is out of bounds or infinity, non-reversible, then we continue. Then we simply update the grid. Grid RC equals grid row call +1 Q dot push RC. Oh. Now the question I want to ask is, will it be this seems wrong, man. I mean, what if the distance updated becomes more? Okay. Okay, so this is the condition that takes care. So if it is not int max, which means it has been updated already, then we don't go there. That's all. What if some other distance is trying to update that, and maybe that might be shorter? I don't know, bro. This seems sketchy. Seems a little sketchy, man. Okay. Okay. Okay, brother. Copy. Let's try this. Run. I want to create one test case here. Let's go. Where is my Xcali draw? I haven't opened Xcali draw yet. That's crazy. Let's say this is infinity. No. 0, infinity, 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 0. And rest of it is -1, let's say. It's just a 2-row thing. What should be the answer for this? Now we get this first in the queue, then we update this as 1, then we update this as 2, we update this as 3. Then we start from here. It sees that this is not int max, so it stops, right? It continues. So according to that code, I believe this should be the answer. Let's see what's happening. Can I create a new test case, bro? What? Okay, I can. Okay. Start 0. This is the infinity thing. Let's just copy this. Control C, Control V, Control V, Control V, and 0. 1, 2, 3, 4, 5. -1. Okay, try this. I want to see the answer of this. Okay, 0, 1, 2, 1. Now, how is that happening? We push it to the queue, right? Then we go to each direction. If it is out of bounds, grid RC is not int max. Am I being dumb here? What's happening? We push it to the queue, right? Initially it will be 0, 0. Okay, let's see here. Cout row call, right? If it is out of bounds, bram. Okay, 0, 0. Value at 0, 1 is this. 0, 4. Pum, pum, pum. Pum, pum. Yeah, so in the queue, it should just be 2, no? No. Okay. Then 1 gets inserted here, it gets pushed there. Shit. I am so dumb. Okay, so what's happening here is we update this one, then 1 gets pushed to the queue. 1, 2, 3, then 1 from goes to 2. No, then we start from here. Fuck. Okay, that's why this works. Fuck, man, that was so dumb. Now I know why this is in the subscribed section. Why this question is paid. Okay, it's kind of confusing. Interesting. Okay, multi-source DFS. Let's watch neat code video to understand why this is the case.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve another graph problem, walls and gates. So we're given an m by n grid where each position could have 3 possible values. A -1, which represents a wall, aka an obstacle that we're not allowed to visit. We're not allowed to visit these walls. A 0, which identifies a gate. So this is an example.
What are we doing? We are solving lead code problems. Yep. Currently trying to understand 286.
Of a gate in this case. And the third value is infinity, which basically represents an empty room. And basically for every single empty room, aka
subbed. Thanks, brother. Thank you.
What's the nearest gate to that room? And then we want to take the distance from that room to the nearest gate and then replace that infinite value with it. So, and if it is impossible, basically, if an empty position cannot reach a gate in our graph, then basically
not PogChan.
So for example, let's take a look at this example. The easiest one over here, right? How far away is this empty room from a gate? Well, it can go right next to it. So it's 3 positions from this gate, but it happens to be that there's a closer gate if we go to the right and then we go up, right? So the closer gate is actually 2 places away, so we're going to put 2 positions as infinity. And it's basically for as many positions as we see going to be of that. Well, a DFS is going to basically be the size of the grid, and we're going to do that for every single position in the grid. So basically it's going to be something like m by n squared. So the question is, can we do better than this big O time complexity? Well, let's try out a BFS solution, right? We tried DFS, let's try out breadth first search and see what that leads to us. Let's say we started our BFS at some arbitrary position like this one. Is it possible that we can eliminate repeated work if we do that? Well, we're going to start here and then visit in all 4 directions and see, what's the closest gate that we can get to. So starting here, we have a distance of 0. It takes us a distance of 1 to get to these positions, and then finally we can get a distance of 2 to get this position, right? But since we don't want to revisit the same node twice, the same position twice, we're going to do exactly that. Once we get to a position, we're going to leave it as visited. So, if we go from here to here, it takes us 2 positions. So, then we can say, okay, for this position, it took us 2. But when we go up, right, we get to this position, we can't really go in any other direction. So basically, this is going to be remaining as a dead end. We're never going to get a distance in this position, right? Because we don't want to revisit the same position twice. We can't go back in the direction that we came from. So a BFS solution starting from the rooms is not going to work if we want to get an actual O of m by n solution. It's not going to work if we do it from the rooms, but let's reverse our thinking a bit. Why don't we do a BFS solution from the gates? So for example, from this gate, we can say, okay, let's mark all adjacent rooms basically as saying, okay, all of the adjacent rooms are 1 distance away from this gate. And then let's continue that. So from, this room doesn't have any other rooms adjacent to it, but this room does. So we can say, okay, for this room, it's 2, and this room, it's also 2. This is 2 positions away from this gate. And we continue, right? We say, okay, this room is 3, and continue from here. This room is 4, and from here, similarly, right, we'd say, okay, this is 3, this is 4, and this is 4, right? But is that actually true? Is this room 4 positions away? Well, we forgot about this gate, right? So a better way of doing this would be to simultaneously do a BFS from...
So my question was, when it is 0, 4, value at 0, 3 is 0, 1, 2, 3, 0, 3 is infinity. Okay, it's just going to one adjacent thing and not following through. Right. It's not following through entirely. Okay, makes sense. Makes sense.
Both gates at the exact same time. So in that case, if we ever reach a position, so let's see what happens when we do a BFS simultaneously. So from here, we're going to say this is one, these two are one position, and this is also one position. Now from all of our ones, we're going to continue the BFS, right? So from this one, we'll say these rooms are 2 away. From this one, we'll say this room is 2 away, right? Now from this room, right, this is 2 away. We're not going to go to this position and say that it's 3 positions away, because this has already been visited. We've already found the minimum distance that this is away from a BFS, right? So every time we expand one layer, we're saying, okay, first let's find all the rooms 1 distance away from a gate. Next, let's find all the rooms 2 distance away from the gate. And 3, and we keep doing that until every single position in our grid has already been visited, or we basically cannot continue. And we know BFS solutions are implemented with a queue, so once our queue is empty, that's how we know we can stop. So let's just continue a little bit more. So from this to, now we're going to exact orderly, I don't know how to do so we're going to have is set wall. So
Okay, makes sense now. I understood this question, man. Okay, let's get to the next one. Okay, rotting oranges, similar to this, I believe. So you are given m by n grid where each cell can have one of these 3 values, 0, 1 and 2. 0 is an empty cell, 1 is a fresh orange, 2 is a rotten orange. At every minute, a fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Impossible means when there are no fresh oranges or when there are no rotten oranges, that is -1, right? Okay. So first of all, we get the locations of all rotten oranges, and then we go directionally, like we spread outwards, basically do a BFS, and then right, yeah, very similar to that. Pum 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 pum. So so there is only one rotten orange here, which is this one. So we start from here. In the first minute, we say that this is rotten now, and this is rotten. Then we add these 2 to the queue. In the second minute, it will be this. Then we add this queue. In the third minute, it will be this. In the fourth minute, it will be this. Yeah, so this is straightforward. Okay. So first we get the coordinates of all the rotten oranges. What happens when there are 2? Yeah, that's why we do a multi-source BFS. Pair of int. We don't even need that actually. We just need a queue for int I equals 0, I is less than q dot push if grid I j is a rotten orange, then q dot push I j. While q is not empty, we get the size of the first layer. Then we simply do this. We get the current one, so int x is let's do this, q dot front dot first, goal is q dot front dot second, and then what do we do? Then we go to all four directions, which are for int I equals 0, I is less than 4, I plus plus. I believe the four directions are, yep. So we calculate x equals rho plus dx of I if x is less than 0 or x is greater than equals m, or y is less than 0 or y is greater than equals n, or grid of x y is empty, which means it is 0, or if it is already rotten, right? Okay, yeah, then we continue. Otherwise, yeah, if it is already rotten, then we also should continue, right? Otherwise, grid of, I made a mistake here. So if grid x y becomes rotten, right? Q dot push x y, and we calculate the minutes. Initially it is 0. I'm not doing a pop here, so that's why it is time limit exceeded. Let's also do some, yeah, let's see. Output 5 5 1. What? Why is this -1? Where each cell can have one of the three values every minute. Any fresh orange, that is, no cell has a fresh orange. If this is okay. So is it starting from 0th minute? No. Okay. We get fresh orange count. Fresh orange count. No, we don't need this, brother. We can simply reduce the fresh count, right? Fresh count minus minus. So if fresh count is 0, then this. Yeah. What? Um, so if it is just an empty space, means there are no rotten oranges. Then it is expecting 0. What does that mean? What? Fresh count is 0. Yeah, fresh count is 0, right? Minutes minus 1. Oh, okay. 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 Let's see. Okay, yep. A lot of edge cases here and there, but it's fine. Okay, I've done this question a lot of times. Nice. Cool. Let's get to the next one. Hello, Sumit Patidar. How's it going, brother? Pacific Atlantic water flow. I'll take a 2-minute break. I'll be right back, guys, and then we'll attempt this question. Cool. Okay, I'm back, boys. So, yeah, I just went to make a drink for myself. It's just tea, not any alcoholic drink, just green tea. I got this Lipton. Let's try. Taste review, tea review. Lipton green tea Tulsi Natura. Let's see how it tastes. We got a nice tea bag in here. Yep. So the back says dip for 2 minutes, so we'll leave this right on the desk. Okay. Andrew Karev, hi from Russia, bro. I decided to start 24 hours lead code challenge today just for myself. I think it's funny way to kickstart my lead code journey. So far, I have 0 solved problems. That's good, man. 24 hours, it'll be tough. I can say that. It'll be tough. Good luck, man. Good luck. Okay. Let's get to the question now. 417 Pacific Atlantic water flow. There is an M by N rectangular island that borders both the Pacific and Atlantic Ocean. The Pacific touches the island's left and top edges. The Atlantic touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You are given an M by N integer matrix heights, where heights of RC represents the height above sea level of the cell at coordinate RC. The island receives a lot of rain, and the rainwater can flow to a neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell. Okay. Water can flow from any cell adjacent to an ocean into the ocean. Return a 2D list of grid coordinates. Result, where result of I is this, denotes that rainwater can flow from cell RICI to both the Pacific and Atlantic Oceans. Okay, so let's take this example. So it's raining on this island. That's perfectly fine. So rain starts from the topmost hills, like topmost altitude, and it starts pouring down to cells with less heights, right? So, for example, if a rain, okay. So rain will start at 7, then it will pour down to 6, 4, 1, and 1, right? Okay. Makes sense. Yeah, we get the idea of what's happening. So okay, so water from cell 7 will go to Pacific as well as Atlantic. So we need to find those cells where rainwater can flow to both of these oceans. Interesting. I'm just dipping my tea on the side. Okay. Starting from 7 and then doing a BFS seems like a lot of iterations. But if I start from the opposite direction, I think that will be better. So simply I will start from this column and this row and find out all of those cells which can be reached. So basically I am trying to simulate water going up instead of going down, because that's the same kind of thing. It's just in the opposite direction. So yep. So we start with, let's say, these things. Then we go to we basically find all of those cells which can be reached by Pacific Ocean and all of the cells which can be reached by Atlantic Ocean. The thing to notice here is we should just go in strictly increasing heights, and that's all. So from 1 we can go to 3, we can go to 2. From 3 we can't go to 2 because it's decreasing height. So yeah, that's what we want to do. Can it go to the same height? I mean, from 2 to 2, is that possible? Less than or equal to, so that is fine. Okay. Okay, okay. Okay, brother. So M and N are 200, so okay. I can create copy of this grid twice and then just do some sort of boolean AND operation on those. So yeah, what I'm trying to say is int m equals heights dot size, n equals heights 0 dot size, vector of vector bool can be reached by Pacific. So I need a shorter name for this. Pacific reached, right, of size m, vector bool n false, and same kind of thing for Atlantic. Then I just do 2 BFS operations and then calculate the AND operation, and that's all. So it'll be kind of m by n solution. Yep. I think my tea is ready. Let's do a taste test of green tea. Cheers, guys. Oh, it's hot. It tastes like shit, but it's good for the health, so it's all right. Okay. So let's write a BFS function. Void BFS. So here we'll pass in the queue, right? Pair int q heights. Damn. Let's call this BFS heights m n. Should I push it to the queue? Yep. Pacific queue, and that's all, right? Pacific reach. So queue of pair int Pacific queue. Now in here I need to just push these coordinates, right? It'll be 0 0 and rest of this first column and rest of the first row. Similarly, I need an Atlantic queue. Atlantic queue, Atlantic reach. Let's also push to Pacific queue 4. So first of all, it is 0 0 and rest of the first column. Rest of the first column and rest of the first row. So first column is for int I equals 1, I is less than m I plus plus specific q dot push I and first column. Similarly, int j equals 1, j is less than n, j plus plus specific q dot push 0th row and jth column. Same thing can be done for Atlantic. I mean, similar thing. Push to Atlantic Q. It will take m minus 1, n minus 1. And then for each row, last column and each row, last column which is n minus 1, so it'll be I n minus 1 and this will be m minus 1 j, right? And this is Atlantic Q. And Pacific reach of this and this are always true, right? Okay. Okay. Then we simply calculate the common cells of these two things and we can return that. Okay. If Pacific reach of ij and Atlantic reach of ij, then result dot push back ij. Okay, someone is getting married outside, that's why a bunch of fireworks. Return result. Let's write this BFS function now. So this BFS function is going to be heavy. I mean, the parameters are quite big. We have int m, int n, Pacific q, the q, and then the reach vector reach. So here we simply do a layer by layer BFS, I believe, right? No, description. Do we need a layer by layer thing? I don't think so. I don't think so. Yeah, I don't think so that we need a layer by layer thing. So we simply say while q is not empty, int x equals q dot front dot first, y equals q dot front dot second, q dot pop. We need the 4 directions, guys. So it is just vector of int dx equals -1100 and dy now. Here go to all 4 directions. If it is out of bounds, then get out. Then if it is reachable, then reach it and add it to the queue. That's all we need to do. So for int I equals 0, I is less than 4, I plus plus, int xx equals x plus dx of I, y equals y plus dy of I, I think I need to remove this tea bag, it's getting stronger and stronger. Oh shit, yep, I need to get this tea bag out. I'll be right back. Okay. So we go to all four directions and then what do? We check. We check if the height of xx, oh, first we check if it is out of bounds. So if xx is less than 0, or we can check the height here itself. So if heights of xx yy is less than heights of xy, then continue, otherwise it can be reached, right? So reach of xx yy is true, and q dot push xx yy, right? Okay. Yup. Right. And we should also do the reach here. So reach of xy is also true because the first layer is kind of a, yeah, we can do that here also, but it's fine, man, it's the same thing. Okay, so I believe technically we have done all of this shit. No, now q should be passed as anything, but reach should be passed as reference because we are updating reach. Percent. I mean, we could create reach here and then get that from here BFS, but it's fine. It's fine. It's fine. It's fine. It's fine. It's fine. Should I do that? Let's do that, man. So we just need this one, and we can create reach vector bool reach equals this. No, not equals, just the constructor. Bam, done. And then we omit reach from here, and we can simply do a return type and then we return reach. So instead of doing this, we can simply say this, right? And same with the Atlantic. It's a little bit cleaner, just a little bit cleaner. Right. Let's do some dry run, guys. Okay. Messed up. We messed up somehow. We need some reach thing. Reach of XXYY is already true. Already reached. Then why are we reaching it again? Okay. Let's see if this does the trick. Okay. What's wrong here? 2 1 and 1 2. 2 1 and 1 2. 2 1 and 1 2. Okay, 2 1 1 2. This is Pacific, this is Atlantic. From here it can flow to anywhere, right? So what's wrong? Just 1 1 is the answer. Why is that? Reach. We are pushing 0 0, and then we are pushing first row and 0th column. That is correct. And then 0th row and first column. That is also correct. Okay. If Pacific reach and Atlantic reach. Okay, if heights of XS YY it's less than XY. Okay. We start from here. We can move only up. Yeah, I mean, pum pum pum. Let's see out. Atlantic 0. Why? Why is it 0? It can reach there, right? Why is Atlantic 0? Am I doing something wrong here? Atlantic reach. BFS Atlantic Q. Atlantic N minus 1. I and N minus 1. I is 1. Oh. No. What? Wait a second. So I pushed this and then I am starting I from yeah, this is wrong, brother. From M minus 1 till 0. Yeah, this was wrong. And J starts from N minus 1 till 0. I think this is the fix. This might be the trick. Yep. This was the trick, guys. Let's see. Yep. So yeah, kind of a long solution. Let's look at some of my previous solutions. Okay, I created a custom coordinate this and then Pacific Atlantic BFS, same kind of shit. Very similar. Yeah, very similar. Yep, quite similar. So time complexity is M plus N, I believe. Let's look at here. Analyze. You have reached analyzing rate limit for today. Upgrade for premium. Well, I can look at here. Oh, what is the time complexity, brother? It's just M by N, right? Give me the time complexity, bro. What's the time complexity? Yeah, Mn. Yeah, M times N. Mn. Correct. Okay, how many? Graph questions are long to write, man. It just takes too much time. Surrounded regions. Okay, so yeah, I'll take a. I mean, let's see. Let's check one more thing here. Okay. Yeah, it's been around 1.5 hours. So yeah, I'll stop streaming now. My brain is kind of cooked after walls and gates, probably. So I'll take a break. Maybe I'll be back today with another stream, or maybe tomorrow. I don't know. So that's it for today. I'll be back soon. So I'll see you guys next time. GG's. Goodbye.